Okay, welcome back. Version 2, similar lecture, just a lot of emphasis on some of the things that we're doing. And let me get you to this one. Let's share this. Good. Okay, and so now this is a slightly different PowerPoint with some of the same things. So overview, benefits, applications, limitations of gas permeable specifically. We're going to focus on gas permeable, like I said. Material properties, the types and composition, and how we select everything. So what are the benefits of GPs? Just like we said last lecture, they're more oxygen to the cornea, better safety, fewer complications. The optics that we put on here, because it maintains its shape, are the optics that we can maintain. It doesn't adhere to the cornea. So for better optics, gas permeables normally are going to help. For irregular corneas, if the cornea is a little wonky, if it's a little wavy, if you've had post-surgical issues, the gas permeable will make almost like a prosthetic refracting surface that goes over the eye, over the cornea, to make it more regular again. There is no better lens than a gas permeable for some of these trouble corneas and unusual corneas. So again, anybody can fit a soft lens. Not everybody can fit a gas permeable because they are a little bit more work and they're a little more complicated, but these are why we focus on these, because the gas permeables are really where it's at. Again, vision, better vision. Eye health, durability, ease of handling. What we didn't mention in the last lecture is it can be used to reduce myopia progression in adolescence and nearsightedness. There's some research going on that a regular gas permeable lens may, in fact, slow down myopia progression when we're born. And as we develop in adolescence up to our teen years into adulthood, oftentimes our eyes get a little bit axially elongated. So most people who are myopic get more myopic in their teen years up until they become an adult, and then it slows down. But it turns out there's more and more factors in that, and there's a whole research end of things that we're going to get into in the third contact lens class about what causes people to become myopic, what causes them to get more myopic, and how can we stop it. And it turns out that gas permeable lenses may be part of that solution to keep people from getting, if a little kid becomes myopic, we may be able to slow the process down. You can't reverse it, you can't stop it, but you may be able to slow it down with specialty lenses and gas permeables specifically. And there's some soft lenses that are coming along that work as well, but gas permeables, in my opinion, are slightly better potentially. Again, cost, environment, well, good vision. One of the things we didn't cover in the last one is astigmatism. If you saw the last video when we were grinding the lenses, they had the curvature. They had the 42 back and forth and the 4375 up and down, or two different numbers. The cornea itself is not spherical. If I put a spherical lens over a toric lens, it makes a tear lens, but it makes a tear lens that has two different curves on the back. So you actually have a lens that corrects for somebody's astigmatism just with a regular old-fashioned lens. And that's complicated. And if you miss what I just said, don't sweat it, because we're going to go over it ad nauseum. But we can put a regular spherical gas permeable lens on virtually the majority of eyes, and they will see very well, even if they have low amounts of astigmatism. Optics are better, how it works are better. You don't need specialty lenses for astigmatism. Some of our gas permeables will correct for astigmatism just the way they are because of the interaction between the lens and the cornea. Great optical quality. You can actually correct for higher order aberrations more consistently. It has great surface wettability. Some of the materials are better than others, and now they have these great coatings that you can put on, like HydraPeg, and it's almost like putting the cookware, what do you call that? The Teflon. It's almost like putting a super slippery, comfortable, no friction coating on the lens. So the lenses are good to begin with, but now we have special coatings that make them even better. Unbelievable with specialty designs. My multifocal patients do much better in GPs than they do in soft. And again, all those corneal irregularities, if you have keratoconus and these other ones, you're always going to do better with a gas permeable, because if that cornea is irregular, but the contact lens over the cornea is regular, the whole system, cornea, tear lens that fills in, and then the contact lens, it's going to see better, and you make the front surface a more regular refracting surface with a gas permeable lens. Eye health, well, why is it better? It's better because there's more oxygen. It's better because there's fewer deposits on the lens. If there's fewer deposit, there's less gunk to be stuck on the lenses to get in through the epithelium to the cornea to cause issues. Soft contact lenses are like gram-negative bacteria magnets. They love soft contact lenses. Gas permeables, less deposit, less attraction to bad stuff, easier to clean off. So because that fewer deposits, less biofilm, easier to clean, less likely to attract, better oxygen. What do we talk about? What's the protectant layer of the cornea? The protective layer, the outer protective layer is the epithelium. If you break down how much oxygen that gets, you're going to start having breaks in the epithelium, and that is your wall against the bad guys. If you break down the wall against the bad guys, they have an opportunity to jump in and wreak havoc. Gas permeable lenses, if they're fit properly and have enough oxygen, generally have a better level of corneal integrity and more oxygen and less problems, fewer problems due to contact lens related complications. Tear exchange, like we mentioned before, every time you blink. Tears that have been oxygenated that are from your lacrimal and accessory lacrimal glands will then replace the tear that's under the contact lens. So you have this exchange of oxygenated tears, but also there's a lot of cell. Remember, we talked about the epithelium migrates over from the limbus, and then it's along the bottom level, but they start to migrate up to the front of the eye and eventually slough off. Every epithelial cell replaces itself 7 to 14 days. There's a lot of cellular debris under there. There's a lot of byproduct under there. By that, a soft lens can trap a lot of that under there. So can a scleral gas permeable, but we'll get to that later. But a corneal gas permeable lens has that tear exchange, so not only does it get oxygenated tears, but it also allows for all that cellular debris and all that garbage to get moved out and replaced with clean, clear tears with their lysosome and everything else that we talked about. It really is a good option. So handling and durability, the GP lenses generally last longer. I will say that the PMMA lenses were indestructible. Soft lenses, they can crack, they can break, you can step on them. But if they're taken care of properly, they do last longer, and they don't need to be replaced every day, every 2 weeks, or every month like soft lenses generally do. They are longer, lower term costs, like I mentioned, easier to insert and remove, in my opinion. They're easier to put in than a soft lens, easily. Disinfecting solutions, pretty straightforward. Just clean it, soak it overnight. And again, they can slow down myopia progression. The cost thing, so the slowdown of myopia progression, there are certain GP lenses that slow down myopia, but there are certain designs, like what's called an Ortho-K specialty lens, that are maybe the best lens out there to do this. And we'll do a whole chapter of this. Cost, imagine if you had 2 lens containers, like little flat packs that you open up for a soft lens, and you put the lens in, you have that little garbage, you throw it away. And again, no big deal, but you're talking about billions and billions of things thrown away worldwide because we're replacing this disposable culture if we use disposable soft lenses. It's not a reason not to fit them, but it is something to look at the larger effect of these and just be aware of that. For the gas permeables, you can use the same lens for years, a year or two. So even though the initial cost may be higher, your chair time may be higher, the lens, you have to get more money for that lens to make ends meet. It is much less expensive than, again, if you ever wanted to look at 1-800-CONTACTS. You can always just look at 1-800-CONTACTS. So this is what some of your patients do. It's useful to go through these sites and to see what they're doing and how easy it makes it, or what the good parts or the bad parts. You should always know what your competition is doing. So if I did a Dailies lens, we'll do the Dailies Total Plus One, and this is, I believe, $84 a box. We'll continue. And in this case right here, it's $84 a box. So, and that's for a 90 pack. So 90 pack should last you 3 months. You need 1 box for each eye. So it's 84, 160, say $170 every 3 months. And so multiply that by 4, 4, 8, 6. So you're looking at close to $700 for a year's supply of these dailies total 1. Well, bring that back to the gas permeable version, and it is absolutely much more cost efficient, cost effective to do a gas permeable than soft lenses. Now, benefits, applications, limitations. What types of gas permeable lenses? We can do the daily wear lenses. You just put them in the morning, take them out at night. You can do lenses that correct for astigmatism. As I mentioned before, most of my regular spherical lenses for everyday use can be used, and the way that they work on the eye can be used to correct for astigmatism. But in some cases, the astigmatism is so severe that I have to do a specialty lens. So we do have lenses for gas permeables that are specifically made to correct people's astigmatism. We have some folks like me who are a little bit old. I need reading glasses or bifocals over my distance correction. We do have contact lenses that correct for that. Irregular, surgical, trauma, if you have scarring, irregularity, if you had LASIK, that's laser surgery to flatten the front surface of your eye, RK, PK, PRK is one thing, or this PK, penetrating keratoplasty. We have some folks that have, for disease purposes or trauma, have to have their cornea surgically removed and a new one sewn on from a donor cornea. Well, those people, that cornea that's replaced is generally not the right shape. It's generally with the sutures, can generally be very irregular. And because of that, their vision oftentimes, even though they have a new clear cornea that replaced their old damaged one, oftentimes you can't see. So you actually have to put a rigid gas permeable lens or scleral lens over this irregularity. So any of these here, if it's really unusual, soft lenses and glasses generally don't work. Gas permeables do. And again, higher prescriptions, people who have dry eye from their regular contacts, higher oxygen demands because of sick corneas. There's all sorts of reasons why you would use a gas permeable, not because it sees better, but because in a lot of cases, it's the only option that you have. The gas permeable versus soft, the gas permeable rides on a tear layer. It's not physically in connection with the epithelial cells. And again, I can't stress this enough. There is an initial foreign body sensation upon insertion. The patient will adapt, they will acclimate. What we generally do is have them keep them in for an hour or two the first day and take them out. A few days later, the next day we put them in, but add an hour or two. The next day we add an hour or two, and generally by the end of the week, they put them in, they don't feel them, they're accustomed to them. It's an adaptation or an acclimation process. However, it is not as comfortable initially as a soft lens. There's no question about it. And that is, for us who want the patient to come in, throw a lens in, and get the heck out, this is a bigger challenge for education and teaching them and going through the process. And to be honest with you, I think more people fit soft lenses just because they're lazy. We've done it as an industry, and it's unfortunate we've gotten away from gas permeables, but I believe there's a good reason and a good market for this. So I think gas permeables should be on your radar if you're fitting contacts. Quality of vision, again, better aberration control. They tend to reduce higher order aberrations better than soft or glasses. Better subjective patient preference, and what's called CSF, contrast sensitivity function. These are higher order issues. These are it's not just can you see the 20/20 line, it's the crispness and sharpness, and it's can you see different patterns and different levels of clarity. And a lot of research has been done to compare before and after, soft lenses to rigid lenses, and not just can you see the bottom line, but how is the quality of your eye, your vision, tested in different ways. And it turns out that gas permeables are better than soft. So a lot of these are the case where you'd put a gas permeable. If you had somebody who's in gas permeable and you put them in a soft lens instead, a lot of times you may get the whole patient, you get them to see the bottom line, but they say it's just not clear, it's just not crisp. And that's because the overall optics of a gas permeable tend to be better. And again, the rigid surface, it doesn't it doesn't dry out for water content. It maintains its shape versus a soft lens can sometimes dry out or sometimes get mold to the surface, draped to the surface of a cornea, which may not be exactly regular. And again, the surface wettability, it stays nice and smooth. Again, ocular health, gas perms don't compress the limbus like some other types of lenses do. And remember, the limbus is where stem cells are. It's where the epithelial cells are produced and then go into the cornea and migrate over and then replace. So if you mess with the limbus, you could actually hurt the eyes long term if you're not careful. Gas permeables don't come near the limbus when they're corneal lenses. Good tear exchange, debris removal, very high oxygen permeability, not just through the lens, which they do, but also around the lens with oxygenated tears. Safer than soft, and this is, I like my numbers. So oftentimes if I have somebody who has a soft contact lens and I have them take it out and I put dye in there and look in the slit lamp, I'll sometimes see a little bit of staining just because contact lenses inherently are inflammatory devices. They cause inflammation. They're little pieces of plastic that don't belong in your eye. It tends to be that the rigid gas permeables create less inflammation and less bother in there. If you looked at soft lenses, for every 10,000 people, there's almost 2 complications, serious complications for, and this is something I'm probably going to ask in a test or a quiz, so please pay attention to that. 1.9, about 2 people for every 10,000 get serious contact lens related infectious diseases processes. If you sleep in the lenses, daily wear, DW is daily wear, EW is extended wear. These are people who sleep in their contact lenses. Older study, but still nonetheless, it turns, and the numbers are still pretty applicable now, you are 10 times more likely to get an infection when sleeping in your soft contact lenses than if you just took them out every day. I know a lot of people sleep in them because it's convenient, but it's just not worth it. And you say, well, it's still only 20 per 10,000. When you're the one that got tagged with the infection, it's awful. And just because you haven't got an infection doesn't mean there's not inflammatory processes. The daily, the gas permeable, on the other hand, it's almost half of the soft daily wear. So if you can cut the risk of infection by half, it's not that you don't get infections, it's just much less. And taking the lens out and doing a gas permeable is almost 20 times safer in terms of your likelihood of getting an infection, a corneal bacterial infection. This to me clearly demonstrates how much safer it is to get a gas permeable lens than a soft lens, especially if you sleep in the damn thing. And again, if you don't get surface deposits, Pseudomonas aeruginosa and Acanthamoeba, this is they're both bacteria and opportunistic pathogens, parasite, if you will. These here don't stick to the GPs as much as they may attract to a soft lens. So we get fewer infections in that regard as well. Again, I don't like this. Approximately half of wearers replace their gas permeables every 2 to 3 years. It should be every year, possibly stretch it to 2. Some people do stretch them. Not as big a deal, but they do get gunky. They do get scratched. Because it's custom made, and this is something you have to take a peek at, because of the custom nature, and you can't get them just anywhere, it makes it so people are more likely to come and visit you. They know the time they're taking. They know the skill it takes. And you just can't go in and get your eyes examined and say, oh, I was wearing my AccuView 2s. I want you to just renew the prescription. You generally have to fit the lens, dispense the lens, verify the lens is working, have them go back for a week or 2, then come back. And then once they're all set, then you can say, this is the lens I'm going to go with. If you're into that type of thing, because GP wearers are custom, they're saying that it generates greater revenue to the practice and softwares. I don't know about that. It depends on where they buy their soft contact lenses. But potentially, I do believe they're more loyal patients. And you're helping them out as opposed to just slapping something on, potentially, as some practitioners do. Again, myopia reduction. It turns out that regular gas permeables, there was one study that they said regular gas permeable lenses may slow down myopia progression, but it really didn't hold out. But there is something called orthokeratology, which is almost like the analogy I would make is it's like Invisaligns like the people who use their braces and the little, it's like Invisaligns for your eye. You put it on your eye, sleep in it overnight for a rigid gas permeable lens, and it reshapes the eye like a retainer. It's a retainer that reshapes the eye so it makes you less nearsighted. You don't wear it throughout the day, and because you don't wear it throughout the day, you have no problems with oxygen issues because your whole eye is open all day. The only time that you reduce the amount of oxygen is when you were sleeping, and it was reduced anyway. But it turned out that this is one of the key things to keep children who are becoming myopic. It slows the process down, and this is one of the key ways we can do this with contact lenses. Again, post-surgical, most people who have corneal surgeries of some type are required to wear gas permeables because the cornea is irregular afterwards. It's not spherical. It's not smooth. It's not well shaped. And so a lot of times we actually will cover that irregular surface with a regular GP, and it'll create a much better surface to refract than they have. Presbyopia, if you're like me and we need bifocals, again, bifocal lenses tend to be in gas permeables for me, tend to be significantly better than the soft lens versions. So GPs are better than soft when it comes to bifocals, if that's what you're going for. Also, some people can't use soft lenses anymore. Sometimes too many infections, too much inflammation, their eye didn't adapt well, they didn't like the quality. So a lot of times you can put them back in a GP if they're willing and educated well enough to take that plunge. And although there is a little bit of an adaptation and it's a little bit more work, you can get people into contacts that thought they couldn't wear them otherwise. Again, what are our limitations? The initial comfort. I can't stress it enough. Initial comfort, lack of disposability. Don't just pick up another one and rock. We generally don't keep a fitting inventory. They're not good for occasional or cosmetic wear. If you wear them once a month, it's not worth it because you can't get acclimated to them. You put them in, it's a little uncomfortable. You don't wear them for a month, you put them in, well, it's a little uncomfortable again. Again, environmental limitations, dusty environments. And then if it's too small palpebral size, well, that's bad for all contacts. But the initial comfort is maybe the one that makes GPs, gas permeables, less popular, period. And I have to say that this is the selling part. If they can go in and put a soft contact lens that's instantaneously nice and comfy, why would they put something that's not comfortable? It really takes a lot of effort and word of mouth and practitioner buy-in. And I think the laziness of us as practitioners and the lack of awareness or knowledge of people in the area, and they're being bombarded with 1-800 contact commercials, they don't know that these exist. So if we don't tell them and we don't fit them and they're not interested, they don't know about them, we can't build this patient base up. Again, there's other things that we'll do. Don't say that they hurt or they're uncomfortable. Just say there's lid awareness. Sometimes there's a little bit of apprehension where the people don't want to do it. I get to use anesthetic drops initially as a doctor. It's pretty cool. And again, I don't say discomfort. I don't say that it's going to hurt. I just say, well, it's going to be, you'll definitely notice it's there at first. And then over the first couple of days, it gets better. I will say scleral lenses, these are gas permeable lenses that are not cornea in nature. This right here, I'm going to actually highlight this. There we go. Scleral lenses, it turns out they're bigger, they're heavier, they're scary as all get out. They actually are rigid lenses that don't fit within the confines of the HVID, but they go from the sclera over the cornea back to the sclera, so they vault over the cornea. It turns out that those are ridiculously more comfortable initially. When we have a lab, hopefully at the end of the semester, we'll do scleral lenses to put them in and take them out and show you what they mean. They are much more comfortable initially than a gas permeable smaller diameter lens, the corneal lenses. Limitations, here you just can't buy them at the supermarket. You can't buy them at the office. You can't just pick up a box of the right ones. They have to be custom made, and therefore nobody stocks these, because you couldn't have custom made suits up on the rack because everybody's the wrong shape, a different shape. Some people are shorter, some people are longer. I have short legs, I have a long torso. I can't have my clothes be custom made and fit on the rack because they won't fit anybody else. I do agree with this occasional cosmetic wear. This here, the occasional cosmetic wear, gas permeable lenses, it takes a couple days to get up and running so that they're comfortable. And if you discontinue, you have to start over again. So if you put it in for a day or two and you're like, oh, this is almost so better, and then went 3 weeks and tried it again, it's not for weekend warriors. If you're going to do weekend warrior, then I would steer you back to the soft daily disposable lenses. Again, too windy or too dusty can be problematic. And for sports, I think there are limitations here. And then the other one is a smaller palpebral aperture size. That's the distance between your lids. I didn't realize this was the limitation when I was just doing it before. There's an issue where if you have long-term, years and decades of contact lens wear, you may find that the palpebral aperture, the opening between the top and the bottom lids, sometimes will shrink a little. So the eyes get slightly more squinty in appearance. Not all the time, but you can see it for people who've had them for 30, 40, or 50 years. Material properties, we talked about this before, the permeability of a material versus the transmission. The permeability is the potential of the material to allow oxygen to permeate through the lens. And if I had a 1 centimeter by 1 centimeter by 1 centimeter block of any type of materials and compare them, I could compare the different materials based on all being the exact same size. The problem is not all lenses are the same thickness. So the permeability is the material property. The transmissibility, or the oxygen transmission, is literally the material, but then how thick did you make the lens? So this is really the one that I like, because the permeability is a byproduct. It's a property of the material, but how much transmission goes through a specific lens is a little bit more accurate, because you're taking into account, one, the material you have, but also if you have a decay of a specific amount and it's a thick lens versus the same lens with a thin lens, it turns out that the thicker lens, the oxygen can't get through the thicker lenses easily. So the thinner the lens, the higher the transmissibility. The thicker the lens, the lower the transmissibility. And this is why this one's more important. Transmissibility is more important, because I could have a super, super high decay lens, but if it's really fragile and have to make it super thick, you may have gotten rid of some of those benefits. So permeability is decay. Transmissibility is decay over the thickness. EOP is something I don't normally cover, but it's in this lecture, so I'll throw it up. And that is how much oxygen measured is going to make it to the back of the eye. It doesn't matter what the decay over T is, if it's a super thick lens, if it's a thick lens, how much oxygen will actually reach the epithelium with this material and the design. Now, there's only 21% oxygen in the atmosphere. You'd be surprised. There's more nitrogen, if you can believe it, than there's oxygen. But it's the oxygen that we have. So what you do is, if 21% of the oxygen is here and you have a value of 21, that means there's 100% oxygen transmission. For the decay over T, how much is enough? Well, if you block off too much oxygen to the eye, it won't be able to operate properly. So they've done a lot of different experiments about how much is enough and how much is not enough. And if you put in a lens every day and take it out every night, how much do you need to eliminate any corneal edema? If you're hypoxic, if there's not enough oxygen, your eye will become hypoxic and you'll get corneal swelling. That's just how it goes. So how much in terms of our decay over T do we need? And it was estimated by this back in the many years ago. It's like sort of the gold standard. Anything over 24 should result in an eye that does not have any significant changes or swelling. Doesn't mean it's perfectly healthy. It doesn't mean there's not some inflammation, but it's enough to not have any measurable corneal swelling. Extended wear, when you sleep in a lens overnight multiple times, you need obviously more oxygen through there, because you now have the lens on morning and night. This was back in 1984. It was revisited, and it turns out that for no corneal swelling upon awakening. So here, the extended wear, this one, the reason why this number is lower is they're saying you wake up and your eyes are a little fuzzy, a little blurry, there's a little bit of swelling. But what happens if you wake up and you go 2, 3, 4 hours, and in a couple hours you measure, there's no longer any swelling? That number's not big enough. The better number is 125. And the higher the DK over T, the higher the transmissibility, the more oxygen to make it through. They said, what value do you need for extended wear for you to wake up in the morning for this experiment with no awakening? Don't wait a few hours. Literally right when you wake up, how's it doing? And in 2000, a much more recent study, they want a DK over 125. So the ones I would remember are 24 or above for daily wear and 125 for extended wear. And that will probably put in some test questions and quiz questions. GP material, for the permeability of the material, we like to classify them. Low is anything under 50. High is 50 to 99. And then we have hyper decay materials. These are generally always silicone based. Anything over 100 for the decay. So keep in mind of that, because this is how we classify them. I'm going to stop there under GP material classification, and we can get into the specifics later, because now we're getting really into the weeds. But again, why is a GP necessary? What are the benefits? Why is it better than a soft lens? Why do we even use it? How do we classify some of the materials? And what are some of the more valuable properties of a gas permeable lens? So we're going to hold off there, because I don't want to give you 6 hours worth of lecture for this week. And we'll share some materials, we'll share some quizzes, and this is great. Thank you very much. We'll talk to you soon.